Hey guys, in today's video, we'll be going over Unit 1.1 of the Math AA SL and HL course, which is scientific notation. Now, scientific notation is basically a way of putting really big numbers or really small numbers in a way that's easy to read and nice for the eyes. And when we put a number in scientific notation form, we basically put it as a way that's bigger than 1 and smaller than 10, right? And what do I mean by this? Now, let's say we have a really big number, right? I'll just use an example. So 270 million. So this really big number, it's kind of hard to read. You have to count the zeros. You have to do all that to read it, right? So how can we put this in scientific notation form? Now, first things first, this 270 million is basically 270 million point zero, right? This point zero does really make a difference. But what we can do is we can take this point here, we can take this decimal point and move it to over here. Remove the decimal point. So then it becomes 2.7000000, right? And 2.7 is a number that's bigger than 1 and smaller than 10. So 2.7 matches this criteria. But now we have this 2.7. So how do we make this 2.7 into 270 million? Well, we just multiply it by 10. That gives us 27. By 10 again, 270. And then you keep going and you keep going until it becomes 270 million, right? But this 10 times 10 times 10 times 10 is basically 10 to the power of 4. So instead of writing times 10 times 10 times 10, I could just write times 10 once. Oh, sorry. Times 10 once and to the power of a number. And how do we find out what this number is? Well, the way I do it is I just take this decimal point and I jump it, and I jump it again, and I jump it again, and I keep jumping it between numbers until I reach the new place. And then we count the jumps. So here it does 1 jump, 2 jumps, 3 jumps, 4 jumps, 5, 6, 7, 8 jumps to get to the right place, right? So 8 jumps is 10 to the power of 8. And this is how you'd write this number in scientific notation form. It's pretty simple. I just use the jump method, to be honest, and it just works every time. And as we said, this is for really big numbers. So what if you had a small number like 0.000479, for example? How do we put this in scientific notation form? First things first, again, we put the dot to make it to 1 decimal point. So now we have 4.79. And this 4.79 here is bigger than 1, smaller than 10, so it matches. And now this 4.79, we multiply it by 10 again. And what do we do this time? We count the jumps again. So 1 jump, 2 jumps, 3 jumps, 4 jumps. So it's 10 to the power of 4. However, this time, so here we counted the jumps and we went forwards, right? This time, however, we went backwards. We counted the jump backwards. So now it's 10 to the power of minus 4. Yeah? So if you put a big number in scientific notation form, you multiply it by a positive 10. And when you put a small number in scientific notation form, it has a negative number, right? Pretty simple. So now we move on to the addition and subtraction of numbers in scientific notation form. And let's say we had this here, right? We had 3 times 10 to the power of 2 plus 4 times 10 to the power of 2. How can we do this? Now let's prove something real quick here on the side. So let's say we had 3 times 2 plus 4 times 2, right? 4 times 2. This 3 times 2 here would be 6, and this 4 times 2 here would be 8, which should give you 14. So this here equals 14. And now what we want to do is we want to take this 2 and we want to factor it out. Okay, so if we write this, we can rewrite this here as 2 times 3 plus 4, right? Because this means, since they're in brackets, this means this whole thing is being multiplied by 2. It's 2 times 3, 2 times 4. And now we just solve it like this. We add these numbers normally. So it becomes 2 times 3 plus 4 is 7, and that will give you 14. So basically, this can be written as this. If they're multiplied by the same number, you can bring that number outside and add the two numbers normally. So we can do that here, where since they're both being multiplied by 10 to the power of 2, we just bring that 10 to the power of 2 outside and add the two numbers normally. So then we'll have 3 plus 4 times 10 to the power of 2. And that will just give you 7 times 10 to the power of 2. And if this here was a negative, this would just be a negative. It would be the exact same thing. It's pretty simple. Now the problem comes when you have different bases, okay? So if they weren't the same. So let's say you had like 3 times 10 to the power of 2 plus 4 times 10 to the power of 4. How can you add them now? Because we can't use this rule because they're different bases, right? So how do we do this? Now, what we want to do first of all is we either want to change this, let me write this 4 a bit smaller actually. So we either want to change this 4 into a 2 or change this 2 into a 4. And obviously if we change this to a 2, this number will change. If we change this to a 4, this number will change. But what I recommend doing is taking the bigger number and always making it a smaller number. So we're going to be changing this 4 to a 2. And now, how do we do this? So 4 times 10 to the power of 4 is basically 4 times 10 times 10 times 10 times 10, right? And 10 to the power of 2 would be these two 10s here. So this would be 4 times 10 times 10 times 10 to the power of 2. Does that make sense? So yeah, 4 10s, we want 10 to the power of 2, so we take 2 of them and keep them. And now these other 2, we just multiply them. So then it would be 4 times 10 would be 40, times 10 would be 400. So it would be 400 times 10 to the power of 2, right? And now we have this in 10 to the power of 2. It becomes 3 times 10 to the power of 2 plus 400 times 10 to the power of 2. And what we see is that when we make this a smaller number, this here becomes a bigger number. This increases, right? And using the same logic, if this became a bigger number, so if this became 4, this number would be smaller. It would be like 0.003. And then we'd be dealing with decimals and it would get weird and messy, which is why I recommend always taking the bigger number and making it smaller. So anyways, now that they're the same base, we can just add them normally. 3 plus 400. And this is multiplied by 10 to the power of 2. And this will give you 403 times 10 to the power of 2. And obviously we know that for scientific notation it has to be between 1 and 10, which means that this 403 here, we're going to have to change it to 4.03, because 4.03 is bigger than 1, smaller than 10. And what's the new number here? Well, this decimal moved 2 points, so it'd be 10 to the power of 2 times 10 to the power of 2, right? Times 10 to the power of 2, which would be basically 4.03 times 10 to the power of 4 using our index laws. Finally, we go to the multiplication and division of numbers in scientific notation form. And this is honestly much easier than addition and subtraction. It's pretty straightforward. Now, first things first, we'll establish two rules. And first of all, 10 to the power of a times 10 to the power of b equals 10 to the power of a plus b. And if you don't know what I just did here, this is one of our index laws, one of our exponent laws, and these are covered in unit 1.5. So if you don't understand what I did here, you can go watch the video for 1.5 to understand. But anyways, this is our first exponent law. Our second one is that 10 to the power of a divided by 10 to the power of b is 10 to the power of a minus b. Okay, this is two exponent laws which you should keep in mind. So let's say we have 3 times 10 to the power of 4 times 4 times 10 to the power of 2. Now, since these are all multiplied by each other, it doesn't really matter which order you put them in, right? So let's rearrange it first. Let's put them in a different order, which would be 3 times 4 times 10 to the power of 4 times 10 to the power of 2. And now you can see this 3 times 4 here. You can just put this as 12. And this 10 to the power of 4 times 10 to the power of 2, as we said here, would be 10 to the power of 4 plus 2, which would just be 6. It's that simple. And again, we said that it has to be between 1 and 10. So we'll just put the decimal point here, which should give you 1.2 times 10 to the power of 7. Okay, so yeah, all you have to do is just rearrange, multiply the normal numbers, and with the tens, you just add the exponents. This is what happens when you're multiplying. Now, what about dividing? Let's say you had, let's say 12 times 10 to the power of 4 divided by 3 times 10 to the power of 2. How do we do this? Now, another rule which we should establish is that a divided by b times times c divided by d is a times c over b times d, right? Now, if we use this rule, we can separate this in half here. We can cut it in half. So it becomes 12 over 3 times 10 to the power of 4 over 10 to the power of 2. And this 12 divided by 3 becomes 4. And this 10 to the power of 4 minus divided by 10 to the power of 2, using this here, would be 10 to the power of 2. And this is actually your answer. So let's put it in pink. Maybe 4 times 10 to the power of 2. And this is your multiplication and division. They're really straightforward as long as you know your index laws. Again, if you don't know how we did this, you can watch Unit 1.5, which covers exactly how we got all the index laws. And now we'll finish up this video with an example question from Cognity. And the reason we're using Cognity and not a past paper question is because scientific notation is a skill which you need to know, and it's not something you'll be asked on. So you're never going to have an exam question that's going to ask you to do scientific notation because, let's face it, this is way too easy for Math AA. So it's just a skill that you need to know. And let's do this example question real quick. So 3.14 times 10 to the power of 5 plus 5 times 10 to the power of 4. So again, what we need to do is make these the same base. Okay. And as I said, we always recommend making this the bigger one into smaller. So 3.14 times 10 to the power of 5 is basically 3.14 times 10 times 10 to the power of 4, which would be 31.4 times 10 to the power of 4, right? And now we have 31.4 times 10 to the power of 4 plus 5 times 10 to the power of 4. Put them in brackets, so 31.4 plus 5 times 10 to the power of 4, which should give you 36.4 times 10 to the power of 4. And we need to move this one across to make it into between 1 and 10. So it becomes 3.64 times 10 to the power of 5. This is our answer over here.